Thank you. Now we've come to the last part of our presentation. You've now heard from Hakan Arnebrand from Metzer Wood about laminated veneered lumber, or LVL, Kurto LVL, and you've heard from Christian Hess from Namibia on glue laminated timber and all kinds of geometric complexities in terms of roof trusses. And you have heard from Petri Pertula on CLT from Stora Enso. And now to finish off, to understand this simple introduction to mass timber, you have to understand how all those elements are fitted together to be able to withstand the various loads that are imposed on that structure. So Mark O'Connor from RHOTOBLAAS is going to take us through some of their connectors and membranes and give us an understanding of what they use and how these elements go together. Just before he speaks to us, Mark joined RHOTOBLAAS team in 2017 as a technical sales agent with a background in commercial concrete construction and waterproofing. And Mark's initial role involved exploring the feasibility of modern and mass timber structures and their context and their application in Southern Africa. And this role has grown to include educating and networking and introducing European know-how to the local market, as well as establishing a subsidiary here and a warehouse to supply the needs of the growing mass timber movement in South Africa and surrounding countries. All right, Mark, over to you. Thanks very much.
Hi, good afternoon, guys. It's Mark speaking to you guys from RHOTOBLAAS, South Africa. I'm going to be chatting to you a bit about connectors, membranes, and some standard details for mass timber and cross-laminated timber buildings. Before I start, I'd just like to say thank you very much to David Elliott from the Mass Timber Focus Group. From our side, we'll be chatting to you about screws, plates, membranes, and tapes. For more info on RHOTOBLAAS and what we're about in South Africa, at least, feel free to give us a follow on Instagram, RHOTOBLAAS.SouthAfrica. And if you're looking for some more info from my side, feel free to email me, mark.o'connor@rhotoblaas.com. I'm going to get stuck straight into it. Here we go. I'm assuming you all know about cross-laminated timber and mass timber, how it's put together, basically the history of the product. What I'm going to be talking to you about is how we can use this material in a building, how we can realize these structures. And I'm going to start with just some basic principles on loading, and we're going to go from there. So we've got two main types of loads. We've got a vertical load, we've got a horizontal load. Vertical loads include your self-weight, your live loads. Typical live load would also be something like snow, something we don't have to worry about too much. Horizontal forces would be wind, and in some areas, seismic sort of loads. If we have a look at this diagram here, we've got a horizontal force, wind, which is acting on this panel. This is a panel in section here. Here where it reaches the panel, it's going to create a compressive force in this bottom right-hand corner. So the reaction force is a pushing force, and that's realized with a long, narrow plate. And this, you're going to have, at this point, you're going to have a lifting force across this rotating moment force, and that is going to be stopped with also a long, narrow plate holding this corner down. And of course, this wind is driving the panel across. So these forces are resisted with these square angle brackets. Here's another diagram of the same thing. Here you've got an F vertical, which is your force coming down here. This is realized by the strength of the CLT panel. In this corner over here, with a hold down bracket, compression with a hold down bracket, and your shear forces are held down across this panel here with your square brackets. These connections are done with either with plates, with screws, or a combination thereof. I'm going to start with screws. We get two main types of screws for structures. You get a partial thread or a carpentry screw, or you get a full thread or a structural screw. This over here is a structural screw. This is a jig designed to insert the screw at the right angle. It's got laser cut engravings on there, so you know that your measurements are correct. The angle is right. It's just to optimize the connection. So just what makes a structural partial threaded screw good to use in a structure? Well, usually the heads are stamped with a code or a sign indicating the manufacturer and often the length of the screw. These stamps are sort of dictated by they certified according to a European technical assessment, certainly in our instance. And along with your stamped head and your ETA, the screws are supplied with a comprehensive product data sheet showing the size range, engineering values. And these engineering values are usually done in spruce, but they can include CLT, LVL, and different types of connections, thin steel, thick steel to timber. Some of the things to consider when looking at a screw, choosing a screw, is your minimum distances from each screw to each other, and the edge from the distant edge from the edge of the timber to the screw. And of course, we would look at your static values to allow for engineering design. These static values or these engineering designs can be done manually, or they can also be done on special software. We've got that software available for download off our website at no charge. So, different types of carpentry and partial thread screws. Let me just show you. This is a catalog of screws. So do not think that this list is comprehensive. We're going to talk about 4 screws here: large head, countersunk head, pan head, or round screw. For your shear connections, partial thread. This creates a pulling effect. So you could consider this screw a puller. Typically, these screws are installed perpendicular to the timber, so at right angles into the grain of the timber. All right, the first screw I'd like to show you, a large head screw. Offers better engineering values than something like a countersunk head screw. Very good values in head pull through and shear, which is very important. Very important for a lot of applications. We find its main application in South Africa, if it's not in cross-laminated timber or mass timber, is very commonly used as a purlin connection to fix panels together and a general carpentry screw. This is a countersunk head screw. It's a screw that we all should know the geometry of, or at least the design. It's general purpose, cost effective, very commonly used, gives you a nice flush finish. In this diagram or this rendering, this is an internal CLT panel. We've got some sealing gaskets or sealing profiles that we've put on either side of the panels. This is a recess, and you have an infill piece that's screwed into position with a countersunk head screw. In our instance, it's usually a 5x60 or a 6x60 countersunk head screw, normally at about 20 centimeter gaps. And that will run up the length of the panel, and that's designed to stitch the 2 panels together. When you incorporate this kind of detail, you have a nice airtight connection. A different type of countersunk head screw would be a pan head or a plate screw. As you can see, it's got a different profiled head, and that's to give you a nice clean design on your steel panel to timber. That's what it's for, steel to timber connections. Very strong connection, nice and quick. And as you can see here, I'm going to touch on this a few times. On the edge of your distance, you have a long square plate, and that's to resist a lifting force in the corners. To connect this plate, you could also use a ring shank nail or a round head screw. Here you can see that not every hole has been filled. This is for two reasons. The first reason is that to respect the minimum distances between the diameter of the screw and its brother. The other reason is that these screws are now enough resistance into this element that you don't need to include any more screws. With a ring shank nail, slightly smaller diameter, you might find that all of these screws, all of these holes need to be filled up in order to realize your connection. Full thread structural screws, these work in a completely different way to your partially threaded or partially threaded or carpentry screw. The main ones that we find or we use in South Africa are the cylindrical heads. This is completely hidden in your timber, and our countersunk head is used primarily with washers or mostly for lifting panels with special lifting hooks. As I said, these screws work along the length of the screw and is considered an actual connection or a locker. It creates a locking effect in the timber. So if you can visualize two pieces of wood, if they're not flush to each other, and you install a full thread or structural screw, and there's a gap between the two elements, you're going to live with that gap. So what can happen is, if you're looking for a very tight, strong connection, you may use a combination of a partial thread to get the elements nice and snug, and then you drive a actual connection through that connection at 45 degrees to lock it in position. These screws are usually inserted at 45 degrees as opposed to 90 degrees. Here's an example of it again with its template. This is a link to a YouTube video just with some general applications. I found it doesn't work the link doesn't work very well when doing a recording of a recording. I will leave this available on the presentation for you guys to look at a later stage. All right, we're going to touch on some angle brackets. I hope that the screws make some sense. As I said, tall angle brackets, perforated plates, are installed at any angle, any openings, or at the end of each run of panels. This is a tensile load or a vertical pulling force. This is to resist those. Your shear or square brackets, they're spaced along the wall at even spacings, and this is to prevent shear loads, or maybe we could describe this as a horizontal sliding force. Once again, the plates are certified and include engineering values. Calculations can be done manually, or they can also be done on software. Here's an example of perforated plates. You get these in pre-cut, or you could also get them in rolls. In this instance, they pre-cut. These orange strips you see between the CLT panels, this represents a soundproofing membrane or soundproofing strip designed to stop noise transmission from your upper level running through to the lower level. Here's the end of a structure. This is on the end of on either side of the openings. So this is really to get into your mind where these are installed. They're pre-cut in a variety of sizes. You can install them with rounded screws or ring shank nails. Very cost effective, simple solution. Here's an example of sort of the various shapes that you can get of them. This is something a little bit more rigid. This is a Titan plate, slightly thicker version of a perforated plate, better engineering values. Here in this diagram over here, we can see it's fixed to concrete. We've got a washer hold down bracket, so for very, very strong connection. We've got a sealing tape. This allows for insertion of some element of waterproofing, air tightness, soundproofing. Once again, WHT brackets. Here you can see in the detailing, they've installed a waterproofing membrane underneath the CLT panel, and that's to stop any capillary action from the concrete entering, or moisture from the concrete entering the bottom of the timber. Once again, this connection is nailed. It's got a hold down washer and a bolt into the concrete. This one has been slotted through the CLT floor to the panel underneath. This is held in position with a panhead screw. All right, membranes and tapes. This is a project a client of ours was doing in the Free State. It's not Apocalypse now. It's just the Free State. These are in the process of being finished. One thing I would like to point out on this rendering, or on this photograph, should I say, is how the battening has been done. So for the realization of horizontal cladding, you always want vertical battens. If you wanted to put vertical cladding, you would have vertical battens, a horizontal counter batten, and then your vertical cladding again. And this is to prevent any moisture sitting directly on the face of your waterproofing membrane and can't go anywhere. So it's just nice to see some of our local projects. As you can see here, it's a concrete little pad that the guys have used to put it on, so you don't have a concrete timber connection or concrete CLT connection. It's sitting on this laminated beam. So fairly basic structure, but it's good to see where the market is going. It's good to see that we are erecting these structures in South Africa. Just some basics on breathable membranes. This is a membrane you typically find or should be specified for the external structure. This allows any trapped moisture to leave the roof, wall or roof structure. The main thing is to keep your insulation and your timber dry. Breathable membranes can either be monolithic, which is a chemical-based membrane, or filter, should I say. This gives you better performance, it's longer lasting, and in some instances can be UV resistant. The other option is a microporous or a filter type membrane. It's a traditional cost-effective membrane. UV, just to give you an example of a UV resistant membrane for open facades, this would be considered an open facade where you have the possibility for UV rays to reach your membrane. You don't want to see any branding on it. Needs to be nice and UV resistant. So in this case, there are membranes available for those applications. This is a CLT wall makeup. You can see your insulation, cladding. We won't see this type of detail too commonly in South Africa at the moment. Here again, inside insulation, CLT panel, outside insulation, membranes, branding, horizontal cladding. If you had vertical cladding, you would have a counter batten running across there. That's good practice. Vapor stop membrane is used internally. This is waterproofing as we commonly know it. It's properly waterproof. This is a vapor stop used internally to stop moisture entering the wall from inside. That's from living, breathing, cooking, showering. These membranes are available in reflective and non-reflective. Commonly, you'll see reflective membranes being used in South Africa normally with steel sheeted roofs, but they could also be used internally on a timber structure. For tapes, these are used for waterproofing and airtightness. You could look at any combination of sealing tapes, expanding foam tapes, and this will allow for an airtight structure, waterproof structure, and an element of soundproofing as well. We have UV resistant tapes. We've got tapes that are available for very cold climates when the guys are working in Nordic regions. Our products, a group of our products are Passive House Institute certified, which means you can get very close to a completely passive house certified building in timber quite easily. Another way of sealing off a structure is a self-expanding sealing foam. These products, got a variety of them are available, easy to use. You could also use foams, spray foams, that type of thing to seal off any air gaps. It's a very common way to detail mass timber buildings. How it's done, again, I'm not going to show you a recording of a recording. Have a look on our YouTube channel. We have got diagrams how to seal off windows, a few other bits and pieces. That's it for me. I hope this was interesting for you guys. And if you've got any questions, please feel free to ask. You've got my email address. Ciao.
Thank you, Mark. That now brings us to the end of this session, introducing mass timber for South Africans. And thanks again to all the speakers, to Hakan, Christian, Petri, and Mark. And we look forward to next month sharing a little bit more of a detailed insight into the introduction for mass timber here with us at the Mass Timber Focus Group. Thanks so much. Bye-bye.